Okay, good morning everyone. Let's start where we stopped in the last class. I think we have stopped in the ILD for SSB as Nandia said. So we will start from after that part. Okay, so we are going to start. Okay, we did this part, is it? ILD for SSB. So I think all of you have understand this and hopefully you have tried by your own also. So after this, we are moving to the next part. Okay, that is ILD for SSB. We are going to do this ILD for cantilever beam. Okay, so there's some brief description about this use of ILD. So what we can do using ILD for SF and BM at the section, SF and BM at the section for any given bending can be found easily. Okay, so now we are going to do what we are going to do ILD to calculate SF and BM at the section due to single point load. Okay, so here you see we are considering a beam, simply supported beam, carrying a moving load W at a distance x from the support A. C is a section at distance z from support A. We are considering a load W, okay, at the point C in the beam. So these two figure B and figure C, are the ILD diagram for SF and BM for the section at C. We already know how we need to find out these values, so we are not going to again find this, so we directly put the value and we are drawing that ILD. Okay, this is for point load. And what is this y and y dash? Y and y dash are the coordinate of ILD for SF and BM at the given load point. Where the load is given, that load, the impact of that load is shown by these two coordinates. Okay, now what we need to remember, all of you please listen carefully. Okay, when this kind of loading is given, means point load, a single point load is given in a particular beam. For that, what, how we need to calculate that SF. Okay, so all of you need to remember this formula. This SF due to given loading position is simply given by W into Y. Okay, and similarly bending moment due to given loading position is given by W into Y dash. Okay, FC and MC is the representation of shear force and bending moment at that point C. Okay, nothing else. So simply when, if we know the load and if we find out the ordinate Y and Y dash, we can easily find out the SF and bending moment for this kind of structure. Okay, so this is the simplest one when we have only one point load. But what we need to do if there is more than one point load? Okay, so now we are going to check that type of loading pattern also. Okay, okay, now here see, in the second condition, that was the first condition, it is our second condition. Second condition is what? SF and BM due to more than one point load. Okay, so for that, see this point one load more than four. So we are now considering four loads. Yeah, you see, here are four load. W1, W2, W3 and W4. Okay, we are considering 4 load in a particular beam. Okay, so now we need to find out, remember we need to find out the ILD at this point C. Okay, so for that, here you see figure A shows a SSB subjected to 4 load having 4-point load, this W1, W2, W3 and 4. And in the next diagram, this Y1, Y2 dash, Y3 dash, Y4 dash, this Y1, Y2, Y3, Y4 coordinate the ILD for SF at section C at a point load W1, W2, W3 and W4. Similarly, in the below diagram, Y1 dash, Y2 dash, Y3 dash, Y4 dash are the coordinate of ILD for bending moment at section C. Okay. So now, see here, what is the difference between the earlier one and this one? For finding out the shear force, and what is the difference between finding out this SF for that single point load or more than one point load? Here you see, there is nothing, only simple difference is that we need to add all the loading system. Earlier it is given by only W into Y, okay, but now we need to take all the loading like W1 Y1 plus W2 Y2 W3 Y3 so on. Okay, we need to consider all the loads. Similarly for bending moment also we need to consider all the loads here, as you can see here, W1 Y1 dash plus W2 Y2 dash plus W3 Y3 dash plus W4 Y4 dash. Okay, and this is the representation of ILD for FC, and this is the representation of ILD for MC. Okay, means at that particular point C. So now what we are going to do, we are going to take a simple example by considering some load so that it is easy for you to understand how we need to calculate it, how we need to calculate all these things. Okay, so is there anyone have any doubt till now? If not, we are going to solve a simple numerical so that you can easily understand what is the, how we need to consider these loads. Okay, there is a simple example I will solve, I will give you. Okay, fine, let's continue. So see, there is a beam given AB. Okay, C is the section here. We are considering 3-point load 40, 60 and 80 kilonewton at various distance from point A, like 2 meter, 6 meter and 8 meter, and C is we are considering at a distance 4 meter. Okay, so what we need to do for finding out the ILD means influence line diagram at this point C. Okay, remember, first of all, these are the steps. Determine the section and draw ILD. Okay, next, what we need to do, we need to find out that FC value and that MC value. And for that, we already know what is the formula FC. It is given by this formula, L minus Z by L, or FC is minus Z by L. Okay, so everything is given. L is given, total length, this is 10 meter. Z we know the distance between from the support A to the point C, it is 4 meter this distance. Okay, so 4 and L is 10. Just putting this value you can easily find out this value. Okay, and for similarly FC you can find, just put the value, you will get this. Okay, and for finding out MC we know this formula, L minus Z by L into Z. Just put all this value, you can easily say what is your MC. Okay, after finding out these two, what we need to do, we need to find out the ordinate. Okay, this is the important part, how we need to find out this coordinate, means this y1, y2, y3, all these things. Okay, so see, in our case there is 3-point load. So for this 3-point load there will be 3 coordinate coming like this, y1, y2 and y3. Okay, so here you see how it comes. This is the representation. This, remember this. Okay, this is the y1, y2, and y3 due to this 3-point load. Okay, here you see C is here. So in the left side of C there is one load, in the right side there is two load. Okay, so we have already find out this point 0.6 and point 0.4 by this formula FC. We have already calculated point 0.6 and point 0.4. We are just simply putting that value. Now what we need to do, we need to find out this y1, y2, and this y3. So how we will going to find out this? Okay, I think all of you remember, you have got in this your school level, there are some condition, equal angle triangle, okay, parallel side, like that. So we can follow this equal angle condition to find out this ordinate. If we take out one portion from this part, if we take out one portion, isn't it look like this? Okay, it will be the same. Again, if we break into two parts, it will look like this. Is it a two part? Okay, this, if we take the big triangle, under that there is a smaller triangle. Okay, if we take out that, it will look like something this. Is it this? So by taking this two triangle and following the equal angle of condition, we can easily say that this y1 by point 0.4 is equal to 2 by 4. This condition. Here you see this. We can easily say this. So from here we can easily find out that y1. Okay. So you calculate this. What is the y1 coming out? From here we can easily calculate the y1. Similarly, if we take the above triangle here, y2 and y3, from that also we can easily, by following this, we can easily say y2 by 0.6 is equal to distance, this distance by the total distance, this and this we can easily find out. Okay, so this is the thing we need to find out. After finding out this, you can easily find out the SFHC. What we need to do, we need to just multiply this all w into y1 plus w into y2 plus w into y3. That will be the SFHC. And similarly for bending moment also, you can also find out that for bending moment, you already know this 2.4 value. Just draw this figure. After that, y1, y2, y3. By considering equal angle triangle, you can easily find out the coordinate of this type of structure also. Okay, just try to do this and finally put in this value in this formula, this and this. Okay, just draw this figure like this, same figure, the figure will be same. Okay, this is the condition. Okay, this is the standard condition, so the figure will be same like this only. For here, for this you try to do by yourself. Okay, for the bending moment part, for the SF part we already discussed how we need to find out this L minus Z by L. Z by L we have already calculated. From that, y1 y2 how we need to calculate, I have already explained here how we need to calculate this y1, this y2, and this y3. Okay, after finding out this, just put here this formula, just put here SF at that point C, W into Y1, W2, Y2 plus W3, Y3. In our case, there will be 3 only, not the W3, Y4. Similarly, you try to find out this bending moment MC due to given loading. Okay, MC we have already calculated this. Just you need to find out the ordinate Y1 dash, Y2 dash, Y3 dash. Okay, W1, W2, W3 already known. Just we need to find out this y1, y2, y3. Okay, please try to do this. Can anyone have any doubt up to this? You can ask me. Are you all listening or not? Or I am just speaking? There is no response from your side. Okay, this is the point load more than one. Okay, if there is more than one point load, then we need to find out this. Okay, I think you can. Okay, let me explain you how we need to calculate that y1 dash and y2 dash y3 dash. See how you need to calculate the y1 dash, y2 dash, y3 dash. Similarly, what you need to do, you need to just follow the similar triangle for that condition. This is MC in the center. We already calculated this side, left side y1 dash and the right hand side y2 dash and y3 dash. Okay, just take out one triangle like this. MC, you know, I think this is we already calculated 2.4 something. Here, just you need to calculate the y1 dash, y1 dash. Okay, so simply what you need to do, y1 dash by 2.4 is equal to the distance. Okay, what is the distance up to y1 dash? This distance here 2 meter and up to C it is 4 meter. So simply do 2 by 4. From here you can easily find out this y1. Similarly, you try to do y2 and y23 dash from right side. Okay, from this triangle by considering this triangle. Okay, you can easily find out this. Okay, let's move on. Okay, in the next condition, this is the condition 3. We have already discussed two conditions. One first condition is for single point load. The second condition is when if there is more than one point load. Okay, and now this is the condition when we are having a UDL. Okay, so what it would look like. Remember, all the figures will be same. Okay, ILD for FC and ILD for MC, it will be same. This type of figure only will get. Just there is a little bit difference in case of UDL. So see here a UDL is given W, okay, per meter span. This is UDL is given. For this, what we need to do, we need to draw the same diagram, but we have to select this area, okay, where the UDL is applied. Okay, so let's go through this. You'll understand when we will go through this. Okay, this area, as you can see, the shaded portion, this is the impact for that UDL is in that shaded portion. Okay, so let's go through this, how we need to calculate this. Okay, see there are three figure: figure A, figure B, and figure C. Figure A shows a SSB carrying a UDL W per unit length. As you can see in the figure, figure B and C are the ILD for SF and BM at section C. So here you will see what is the difference between the earlier and this one in case of point load and in case of UDL. What is the difference? Okay, here you see. Therefore, SFFC, this SF at the point C at a section C due to the UDL is, okay, it is given by C what? In the earlier case, it is simply given by what? W into Y. Okay, in case of point load, this. Okay, but for UDL, what it is given? C. It is given by W into area of the shaded portion in ILD. This area of the shaded portion. Remember this. W in place of Y, now we need to consider the area where the UDL is applied. Similarly, for the bending moment also, it is given by C, W into area of the shaded portion in ILD. Okay, at that point C. Remember, whatever point load or UDL is given, we are going to find out at a particular point. Okay, because ILD is the representation of a load in various point. Okay, it is a moving load, so we need to find out the load at any particular point. So we are considering C as a point, so we are going to find out in that point. Okay, so let's take an example. See here, we are taking a beam AB. We are considering a UDL 20 kilonewton per meter. Everything is same at a distance C, 4 meter from A. Okay, this usually start at a distance 2 meter, ending at a distance 6 meter. Okay, here you can see it is starting at 2 meter and ending at 6 meter. As you can see this, okay, 6 meter. So first, similarly, what we need to do, SF at C, just find, put all this value FC, find out FC. Similarly as earlier, the formula will be same, L minus Z by L. Just put this value. Okay, you will get the value FC. Maximum bending moment also you can find out by putting the in this formula L minus Z. This formula L minus Z by L into Z. Just put in this formula. Everything will be same. Next, calculation of coordinate. It is also you have to find out by the earlier one. Similar thing. Here you see same thing for this. Same way you can find out y1, y2. Okay, y1 dash and y2 dash. Try to find out this y1, y2, y1 dash and y2 dash. Okay, remember there is y1 and y2 dash because the UDL we need to consider the starting and the end point. Okay, for the UDL there will be two ordinate. When we draw the figure you will understand. So now what we need to do, we need to find out the area of that UDL portion. Okay, for this UDL portion we need to find out this UDL portion, what is the impact of that in that particular area. Just give me a second. Okay, Okay, fine. So what is the impact of that area? See, when we draw the diagram for SFE for this type of beam, what it will look like, it will same, okay, same this way. Just draw the SFC at the center, draw this line, okay. Here it will be two ordinate, okay. This will be your y1 and this will be your y2. So everything we know, just we need to find out the y1, y2, okay. Already we find out this fc value here, it is 0.6 and here below it is 0.4. The distance we know. Simply following this we can easily find out y1, y2. And for the bending moment also, excuse me, for the bending moment also, the two coordinate will become y1 dash and y2 dash, okay. So now remember, listen this, okay. Area, how we need to find out this area, area a1, a2, okay. If we consider this as area a1, this and this as area a2, how we need to find out? See, this is what, if we take out this portion, if we take out this portion, it will, isn't it look like a trapezium? See, if we take out the area, this from here, this portion, if we take out this portion, this shaded portion, here also you can see this shaded portion. If we take this as for example, this shaded portion, this a1, a2, it is written here, see, a1, a2. If we take out this shaded portion, this one, okay, this shaded portion, isn't it look like a trapezium? Also, when we take out this portion, isn't it look like a trapezium? So what we need to do, we need to find out the area of this trapezium. So can anyone tell me what is the area of a trapezium? How we need to find out? I think all of you know the trapezium formula, sum of the parallel side divided by 2 into the distance between these two parallel side, okay. So here in our case, what is the parallel side? This line and this line is our parallel side, okay. When we draw this line and this line is our parallel side, we already know that this value, what is this? This is 0.4 and this side we have already calculated y1 as 0.2. So here you see 0.4 plus 0.2 and the distance between these two lines, it is 2 meter. So 2 multiplied by 2 and divided by 2. Similarly, when you consider the above portion, this portion, this shaded portion, this, by considering the trapezium again, you can easily find out the area for that section. Similarly, we need to find out the for this portion and for this portion also by considering the trapezium, individual trapezium, okay. This a1 dash and a2 dash. It's very simple. You can see easily you can find out this a1 and a2 dash, okay. After this, what we need to do, we need to follow this as condition is given in the condition w into area of the shaded portion for finding out the SF and w into area of the shaded portion to finding out the bending moment, okay. But remember which area we need to consider. You have to remember that for the SF we need to consider this, and for bending moment we need to consider this figure, okay. So now here you see what we did. Here you see SF at C, W into A1 plus A2. Simply just put all the value, you can easily find out that SF. And bending moment at that point also, you can easily find out W into A1 dash plus A2 dash. We already find out A1, A2, A1 dash, A2 dash. Just put all this value, W you already know, it is given. Just put and fine. Okay. Okay. Is there anyone have any doubt up to this? You can ask me. Okay. Or all of you, please give your attendance in the chat box. Okay. Is there anyone left to give the attendance? And is there anyone have any doubt? Please ask me, or we are going to stop this. Okay. We will continue in the next class. Okay, then everyone, thank you all. We will continue in the next class. All of you, please go through this. If you have any doubt, please come up with that in the next class. Okay, thank you all.